Let's talk about a process that's probably familiar to most of you. That's the typical manufacturing process. Now, when we design a new product, we usually start out with a concept. Designers start quickly sketching out a bunch of ideas, then they start to refine these rough drawings into more polished designs, a handful of them maybe. And then they'll go into design review with various decision makers, where engineers will finally get their first look. And that's where the question first arises. Will my design intent survive the engineering process? We can call this first part of the process the design phase, and it's really about the continual evolution of an idea, what the idea looks like, or how a user might experience it. Of course, there are various subphases within the design phase, like reviews, dimensioning. But traditionally in manufacturing, this has been a discrete phase that results in a finished output, the finished design. And after a while, this finished design and a bunch of binders get tossed over the wall into the next department, engineering. And that's where form and function begin to merge. Which sounds easy, but often it's actually quite archaic, because as you know, engineers and designers don't always use the same software. So the engineering department might have to recreate the designs to work on them. And of course, communication over these walls is often difficult. The designers have made lots of big and small decisions about the look and feel of the product, a type of plastic, for instance, or the sweep of a curve. And the engineers have no way of knowing which decisions are vital to the product and which can be changed so the creative vision can actually exist in the real world. So they go back and forth with design several times, and the final design turns out not to be so final after all. Of course, this is just a simplified example, because as you know, there's no such thing as engineering the way most people would understand it. That generic term really includes mechanical engineers, electrical engineers, materials people, and on and on. So not only do engineers have a difficult time talking to design, they can have a rough go of it talking to each other. Clearly, the typical manufacturing process is far from perfect, but it's what many of us are used to. And let's not kid ourselves. The walls that separate design from engineering, not to mention manufacturing and marketing, have their uses. Consider what it would be like if design were only halfway through the brainstorming process, and engineering was building models based on data that was practically guaranteed to be obsolete in a week. It would be a huge waste of time and money. Unless there was some way to manage, revise, and share all of the data automatically, to capture the changes in real time, to break down the walls and allow collaboration around a single data set that design, engineering, manufacturing, and even marketing could add to as needed. And that's what Autodesk Vault software does. It enables the secure and coordinated exchange of your idea throughout its evolution. Decisions don't get made in a vacuum. They get documented, recorded, and stored in a central location. Imagine the process we just talked about, but without the walls. Designers start to create, and engineers can see the ideas already. They can start to investigate tolerances or a material's performance from the same data. And when the design changes, that decision gets processed and documented. And the engineering drawings get updated as well, and tooling and simulation and visualization. Autodesk Vault becomes the single source of all design information. So all that back and forth between design and engineering that once took weeks or months is now happening in real time. It doesn't even matter if they sit next to each other or on different continents. Designers start to think and anticipate like engineers, and vice versa. And even within the engineering department, the electrical team and the mechanical team can work on different aspects of the project at the same time. Or a coder, for instance, could write software for a robot before it was even built. So now you can see how the whole process can get accelerated dramatically, and yet safely, because everything gets documented. Even the bill of materials can get updated in real time, so that management has an accurate idea of costs. And that, in a nutshell, is what Autodesk Vault does. It helps you get your products to market more quickly, without losing the integrity of your creative vision. And here's the kicker. Here's what gets designers and engineers and manufacturers and marketing people really excited. When you purchase Vault, it's built right into the interface of the Autodesk software you already use. So you really don't even have to change the way you work. The whole manufacturing process just changes around you. Now let me say something to those of you who are wondering just how long it would take to start streamlining your engineering process with Vault. Hardly any time at all. That's right. Starting with Vault takes virtually no time. It works right out of the box. Which begs the question, why isn't everyone using Vault? Well, many are. Autodesk Vault is used by thousands of consumer product, industrial machinery, building product, and automotive companies. Because as you've seen, Autodesk Vault is much more than just an ordinary data management tool. It's a way to transform your entire manufacturing process.